All right, let's start. Introduction to serverless. Ready? Thanks for sticking around for the last session. I hope people don't fall asleep. So thanks to all our sponsors making this all possible. Brace yourself, buzzwords are coming, and lots of them. So the topics, I want to introduce myself, really short talk about cloud computing, then dive into serverless, show you examples, and tell you how you can get started yourself and some next steps to explore, and to end with some conclusions. So who am I? I'm Robert. I'm a technical director at MediaMonks, and for some that do not know us, we are basically one of the biggest production agencies in the world, and we just opened our 12th office last week in San Francisco, and in total we're with 700 or 750 people or 800, I honestly don't know. And I'm also a PHP department lead, and next to that I'm also called Beer Monk because I'm really much into beers. And I'm also a proud Windows user, which is just a fun fact. I'm proud to use Windows. So cloud computing, this is something I hear a lot. It's just someone else's computer. And I don't really agree on this, because it's not just a computer. It's possibly hundreds of thousands of computers all working together, and if one dies, a new one is spawned and you won't even notice. And the big cloud providers can provide such big SLAs that you can never do yourself. So I think it's very unfair to say like it's just someone else's computer, because it's so much more than just that. So when you do compute on cloud, you have VMs, also called infrastructure as a service, which would be something like your EC2 instance. Or containers, which is the new thing. You can do Docker or Kubernetes on AWS and all the big platforms. And something relatively new, it's been there for a few years, but it's getting some traction now, functions. And they refer to it as functions as a service, or FaaS. And also on the cloud you have services for everything. So you have storage and databases, queues, and whatever you can think of, there's a service that has this, that can do that, what you want. So serverless, it's a weird name, right? Because of course there's still servers involved. The code has to run somewhere. So you can compare it with wireless internet. This is a quote from the creators of serverless framework. Just like wireless internet has wires somewhere, serverless architecture still has servers somewhere. Makes sense, right? What characterizes serverless architecture? It means there's no servers to manage or provision. It auto-scales based on load, and the cost is based on precise usage only. And it's also highly available and fault tolerant by design. So what does that mean? It means you focus on code, not on servers. You don't have to worry about all of that. So if you create a function, just a piece of code, how would you run that piece of code? What can invoke that function? It can either be push-based, which is then synchronous, and this could be like an HTTP call. Or it could be some kind of chatbot. Someone is typing a question, you get the request, and you need to reply immediately. Or authentication. Your service needs to know if some kind of token is valid. It needs to be validated synchronously. Asynchronously, I think, is also very, very interesting, very powerful. It could be something like if you added a picture to an S3 bucket, or if some database change happened, or if you receive an email, you can trigger a function. Or cron, maybe run a function every hour, every minute. Or if someone creates a machine, Netflix uses this a lot internally. Whenever someone creates a new system in their account, there's Lambda functions checking if actually it has the right permissions, if it's not accessible from the outside, and if it is, then the function will immediately terminate this machine. A third option, poll-based, this would happen for queues and streams. So it won't invoke a function for every item that's pushed on the stream or the queue, but it will just poll to see if there's any changes, and if there's more items in the stream or the queue, it will create more functions that are polling for new items. And also you can manually invoke functions using the API. Also very handy. Common use cases for serverless. It could be a simple static website. Just run a website from an S3 bucket. Or APIs, microservices. Content processing, like you can have a user upload an image and you can detect what's in the image or do automatic resizing as soon as someone uploads it. You don't need to have a full server for that, doing all of that. Audio video rendering, very powerful feature. I actually have a use case later on that you can have MP3 rendering or rendering of video with FFmpeg in your Lambda function. Data pipelines, whenever an order comes in, you can transform that order, add some data to it, remove some data from it, maybe mark somewhere that an order is processed. Email handling, whenever you receive an email, you can decide based on the content of the email to do something with that email. Or chatbots, like I previously mentioned, like Google Home, Alexa, they're all using this. So if you want to work with databases, you have some flavors at the different providers. I have most experience with AWS and Google Cloud Platform myself. Of course, it means that there's other cloud providers and they have their own services. I just know most about these. So for Amazon, it would be DynamoDB, Elasticache. I'm a big fan of Redis, which is offered within Elasticache, or Aurora Serverless. And this is relatively new, but Aurora is a MySQL compatible database, and whenever there's no traffic, it won't run. So there's no cost for that. And whenever traffic comes in, it will automatically scale up and down. It's really powerful. On the Google side, there's a real-time database of Firestore. Those are both databases within Google Firebase, which I'll get back to later. Memory Store also offers Redis, and Cloud Data Store. Persistent storage, I think everyone knows S3, and on Google Cloud they have cloud storage, and fun fact is that they're actually compatible. Google made it compatible with S3, so you can use basically any library also with Google Cloud. Very smart choice, I would say. And of course there's servers for that. Like you can, if you need to have content, of course you can do Drupal, and also have a use case for that. But if you actually want to go serverless, then there's a lot of providers that offer headless content, like Contentful, Prismic, Flamelink, and forms. There's many services out there that just allow you to build forms, and it offers a API where you can send the data to, and it just captures everything. E-commerce, Shopify, I think everyone knows Shopify, Snipcart, Foxycart, just a couple of lines of JavaScript and you have added e-commerce to your website without running a server. Authentication, Auth0, Okta, Cognito. Cognito is a service from AWS. It allows you to connect Facebook and Twitter to your website, log in with that. Very easy, just some JavaScript. Serverless also has a few limitations. It's stateless. So the service or the function can run a limited amount of time. I believe at this moment it's 15 minutes at AWS. I think Google is a lot shorter, and it doesn't keep state. It's short-lived, and it can suffer from cold starts. And what this means is that if your service isn't used in a while, it can, like they are internally using probably containers for this, and they won't keep all the containers running if no one is using it. So whenever someone triggers the function, it takes a while because they need to boot the new container or the VM that's running it. And depending on the provider, that can take for 100 milliseconds up to a few seconds. And it can be quite hard to debug. Like if you have a function, you uploaded it somewhere, you need to add some logging and figure out where that's going. It's sometimes more difficult than like doing it with Drupal, for instance. So I think this will give you a general idea, examples, because that's what it's all about, doing actual code. So if I would have a static website, and I've done this many times now, I've just taken a Symfony website and decided like, all right, why does it even need a server? Why am I running a VPS for this website? It's getting a few visitors a day. It's a waste of money. So what I did is I took Google Firebase, and they offer a few functions, a few options, so you can run an API through Cloud Functions, which runs JavaScript. They offer a free database, they offer hosting and storage. And the difference between hosting and storage is hosting is where you put your HTML, and storage is where you put like photos or videos. So that's the difference between the two. You can also put that on hosting, but hosting is more expensive than the storage. So as an example, this site has pretty much no functionality. It just features an image gallery, and it has a form which someone can enter their data, and then I will contact them. So I've created a function that just uses Google SMTP to actually send the email to my own Google account. And now I don't need to have a server at all. There's no VPS running. It's just some code I uploaded. I don't have to worry about it. I don't care if it has 1 visitor a day or 100 or 1,000. They will scale it for me. And if I want to add new photos to the gallery, I just get a JPEG, I upload it to the cloud storage, and then automatically it invokes a function, and it will add an entry to the database. It will create a thumbnail, and then push the new content to the website. That's all I have to do. I just drag and drop an image into a bucket. Then another example. This is not sure if anyone doesn't understand Dutch, but basically it says, "Is it beer time?" We like our beers at the office, and we take it very seriously actually. So we created a website for it, or I did actually. And also this is running on Firebase, because I saw a presentation on Firebase, and the first thing I started thinking, like, all right, what can I do with Firebase? And this was like the 5th iteration of the website, so I decided to make the 5th iteration of the website on Google Firebase and not worry about a VPS that can go down. So how does this work? I have the hosting, there's my HTML file, and I'm using authentication because some users are allowed to actually decide when it gets beer time. And there's a database keeping track of these times. And there's an API available because we have some devices at the office, including a mobile app. They can read out the API and see if it's beer time or what's the reason for it. And I actually have a button which I will show in a few seconds. So the website looks like this. It's very basic. Currently it's Friday past 4:30, so it's beer time. Very good. My co-workers are very happy right now. And if I just start nagging them now, I will change the time, and then you will see the time changing immediately. And this is not something I had to put a lot of effort in. It's very easy. Once you change something in the database, the real-time database from Firebase, it gets pushed to all the connected clients, and you can act on that change. So let's put it back there before someone notices and gets angry. So doesn't matter if there's 100 clients connected or 1,000, this will get updated immediately. Very useful. And this is the dashboard of Firebase, and here you can basically see the same thing. So if I look at the times field, there it is, start. Here you can see the time, and if I change it back to a little earlier, there you can see it updating immediately. And basically that's also what it does in the front end of the website. And I also mentioned the button, and this is why I said we take it very seriously. Not sure if everyone can see, but this is an actual hardware button, and we can use this. It's protected by a key, because otherwise people would start pressing the button all the time and making it beer time, which is at some point is really good, but we also have to do some work. So I protect it with a key, and I have a key, and I gave someone else a key who I can trust. And whenever I flip the key, it will connect to the Wi-Fi of the office. The LED starts to go on whenever it's connected. Then I can press the button, and it will call the API and make it beer time, and everyone's screen will update automatically and see that it's beer time. And that's just, it makes it fun to try new stuff. I think this really helps. If anyone is interested in how the hardware looks internally or what's internal in the button, then find me afterwards. I'm happy to explain. So that's the beer time. Also, I forgot to show Untapped. Is anyone using Untapped here? All right, a few people, good. We should totally be buddies there. So you can do these check-ins and show people that you're drinking beer. Also, I made a small ticker at the bottom of the page, so whenever someone checks in their beer at the office, it shows it in the ticker. And this is actually a good thing to know when working with Firebase, because as I will tell you later, it's basically free to work with Firebase. But as soon as you start to call an external provider, you would need to pay for it. Also, I'd like to use serverless a lot at home. I've got a network attached storage at home, and I'm running a VPN service on that, and I like, whenever I'm not at home or at the office, I like to connect to my own VPN. But of course, I'm on a consumer line at home, so basically my IP address is static, but sometimes it does change. It happens like once a year or something. But if that happens, I want to make sure that I always connect to the host name and it should go to my actual IP. It should resolve to that. So what I did is I created a small script that's just calling an API endpoint on API Gateway at Amazon, and there's a small piece of code, and the only thing it does, it takes my current IP and it updates it at my provider where I have my domains hosted, which is in this case LeaseWeb. And I can show you this piece of code. So you get a general idea on how a function actually looks like. So in this case it's Python, and basically you get an event, and I'm checking if there's a query string parameter because I secured it with a token, and the token is also in my NAS, and it will check if it matches, and if not, then it will kill the request. But then I'm updating my subdomains at my provider. I'm just doing a put request there, and I make sure I run this every 15 minutes, so whenever my IP changes, within 15 minutes, it will update my IP, and I can connect to it again. So this is just an example of something really tiny. I need to do a small thing, and I don't want to have an entire server running for this. Also, I don't work with papers at home. I have a paperless home. You hear about paperless offices. I have a paperless home. Whenever something comes in, I scan it with OCR, I upload it to my NAS, it will synchronize to an S3 bucket, and I throw away the paper. And I also have an Elasticsearch instance at home where I can search for documents. So whenever I need to look up something, I just type it in and the PDF comes out. It's very useful. But I wanted to make sure that whenever something is updated in my bucket, I wanted to know about it, because maybe for some reason someone else gains access, or Amazon decides to remove something. Maybe I made a small error in configuring my S3 bucket and some document gets removed. I wanted to know about it. So I created a small Lambda function. Whenever some change happens in that S3 bucket, I add it to a queue, and every morning I empty the queue and then send an email with all the changes that happened, and then the queue is empty again. So for that I'm using CloudWatch. It's a simple cron. So every morning it triggers a function, it reads the queue, sends an email, and done. Very useful. Again, no server required, it's just a few pieces of code. This is an actual project we did at the office, some audio rendering, and the use case was that there was some user input. They had to fill in a few questions, and then a customized audio file was rendered, an MP3 file was rendered, and then it would display, it would load in the site, and that would complete your experience for the campaign that we were doing. And it needed to be highly available. They would expect a lot of traffic, so we decided to do this without servers, and the site actually was running from CloudFront, and it was getting its data from an S3 bucket, so it's just all static HTML. And whenever someone entered their data, it would send a request to a Lambda function. It would return the URL where it could find the MP3 file later on. It would just do the rendering, and after like 30 seconds, it is usually done. And then we just do a request from front end to see if the file is actually there. And if it's there, it would just load and complete the experience. And if it's not, we would wait another 5 seconds or 10 seconds and retry. And this worked really well. We got 10,000s of hits on this every day, and we didn't have to worry about scaling at all. It was all taken care of automatically. This is a pretty complex one. I don't expect everyone to understand what's going on here right away. But this is an actual game API that we're building right now. It will go live in January. And this is a fully serverless game API. Well, not fully, I will explain that later. But the entire game API itself is serverless. And it's using API Gateway again with Lambda functions and Redis as a NoSQL database. And we are using Kinesis. Does anyone know Kinesis streams? Okay, basically what a stream does is you write some data to it, and you can compare it like a queue. So you add some data to it, and there are 0, 1, or multiple consumers reading that data. And this is highly scalable within Amazon, and it's fairly cheap to use. Eventually it's a lot cheaper to use this than a queue like SQS at Amazon. And also this does some polling. So whenever you write something to the stream, you can read the data in a function. It will get invoked multiple times a second to see if there's new data and if there's something we can act on that data. And we have lambdas writing new, maybe based on the events that are happening in the game. So maybe someone unlocked an achievement, and then we decide we send that to the stream, and then there's a function listening to, all right, someone unlocked this. Let's give this user some credits because they unlocked this. And we will just send that update back to the client using WebSockets. But maybe that function will trigger a new event. Maybe it will trigger a new event, and it will just send that back to the stream, and other functions might react on that instead. Also, we are storing all these events in an S3 bucket. So if the database for some reason gets corrupted or we want to change database, we would be able to reread all the events that happened, put it in a new database, and continue from there. This is actually called event sourcing. It's very powerful. It could have a session of its own. So I don't want to go into too much detail there. Also, there's all the events are going into Elasticsearch, which you see at the bottom. And we have a Kibana dashboard there where we can see how many events are coming in. So you can generate some really powerful statistics there. At the bottom in the middle, there's a small purple block there, and it's actually content management, and it says Fargate. And Fargate is a way to run Docker containers in Amazon without worrying again about scaling. However, I don't consider Docker containers on Amazon to be serverless because we still need to scale up and down based on traffic. So I don't think this part is actually serverless. This part, this content management system, is actually running Symfony Framework with Sonata admin. However, this could easily be a Drupal instance. And we also have planned a few projects where maybe we will go with that route instead. So Drupal can still be a part of a structure which is like 90% serverless, but you use Drupal or another CMS as a headless CMS. As you can see also, this is using a relational database on the right side. It's just MySQL. Also something fun, as I told you, I'm very much into beers, and I have a friend that's more crazy about beers than I am. And we like to go to festivals where you have beers, and they like to publish all the beers that you can drink there in advance. So sometimes there's up to 300 beers that you can have at a day. And this friend of mine really likes to, he's kind of an Excel geek, so he likes to create all these spreadsheets with all the numbers, like what's their average rating, what's the best beer that I can have these days. And he spends a lot of time with that, which is cool. And I wanted to use the data in an app, but as a developer, I'm really lazy, right? And I wanted him to do the work, and then I wanted to use that data as well. So I gave him something more as a proof of concept, but it turned out to work really, really well. Let me first show you how it actually works. Then you have a better idea. So I gave him this spreadsheet, and it's fully empty. And what he used to do is he would go to the beer list, and then look up the word, look up the beer in Untapped, and then paste all the data, copy paste everything in this list, and then he would have his list. I would import the Excel, but I wanted to be a little more nicer to him, so I created this for him. Basically, I copied the deep link of the beer, and as you can see, there's an identifier here in the URL. And now I'm just pasting this link in, and then it takes a few seconds, depending on the cold start. It takes a little longer. And in the meanwhile, while it's loading, there it is. What it actually does, I'll show you, by the way, that the second time goes way faster. Then you have an idea on what the cold start actually means. Now it should be a little bit faster. And once you add more stuff to the sheet, you can also add multiple at once, and it will just put it there, multiple at once as well. Alright, well, Google is not really working with me. How does this work? As you can see, here's my spreadsheet on Google Drive, and they have a thing called App Script, which is really, really powerful. I didn't know it existed. And you can do something whenever something changes in the sheet or a document. In this case, it's the sheet. And what it does that he pastes in the URL, I look up the ID, I replace it if needed, and then I add this ID to the Firestore database. And whenever there's something newly added to this database, I will trigger a function and look up the data in Untapped. And whenever that data, when I get it back, I will update the database, and whenever something changes in the database, I update the spreadsheet. So that sounds fairly simple. And let's remove it again. Let's try again. Now it's really, really fast. And you can actually see it here as well. So this is the database that's like the main source for the data. And here you can see all the data of the beer. And whenever I change something here in the sheet, I update it, I go back to the sheet, and you see it already changed. So it's really, really cool features, and there's no server running anywhere. It's just a bunch of scripts reacting on changes. And with using this, it was for him really easy to just copy paste a few links. All the data would get updated automatically. He was able to export his data as a sheet, and I would be able to use this data in an app. I actually didn't because I was too lazy to actually create the app, but still, it was a fun proof of concept, and he was actually able to use this. So if you want to get started with this yourself, where do you begin? Luckily there's many providers which actually support this. Like I said, I have most knowledge with AWS and Google, but there's a lot of other providers that support kind of the same things. I showed you a lot of examples using Google Firebase, and this is a really, really cool product that they have. It focuses on web and app, and it has a cool SDK and a CLI tool. So you just create some data, you type in Firebase deploy, and it will just deploy, and you will get the URL where it's running. It supports Node and Python, no PHP. And they have a very, very generous free tier. So if you start with this, you can do like a few 100,000 invocations of a function every month. And they have like 1 gigabyte of free hosting and 5 gigabytes of free storage. It's extremely generous, and a lot of stuff you can just run basically for free. The only thing is that, like I said before, if you're running something you want to access an external party, in this case Untapped, they don't allow it. They only allow data within the Google network. So for beer time, I actually switched to a paid plan, which is pay as you go. And it's still, they give you all the free tier stuff. So that's still all for free. So I'm only paying a few cents a month for running the website. It's crazy. I was paying like 10 euros a month for a VPS. Now I modified it, and it only cost me a few cents a month. Amazon, basically it's separate services. So it's not as easy as doing this with Firebase, where you just say Firebase deploy. You need to use other tools or do it manually in their UI. They do support a lot more languages. Again, no PHP. And they have a really cool web console using Cloud9 IDE. So again, very powerful app. It has some highlighting. It's not as powerful as your own IDE probably, but it's still very powerful. And they have a CLI tool as well. It's called SAM, Serverless Application Model. It's like a description on how to define a template at Amazon. And they offer many examples on their own GitHub. Also, Amazon has a free tier. You can run, I believe, 1 million invocations a month for free. And this is ongoing. So a lot of the free tiers at Amazon stop after 1 year, but Lambda is ongoing. As well for the queue. So my example showing the queue, it costs nothing, because also with SQS you can have, with the queuing system, you can have a certain amount of free items in the queue. AppSync, this is relatively new. It is from Amazon, and I think it tries to compete with Firebase. It's also focused on web and app. It's real-time push-based, and it uses GraphQL in DynamoDB. That's the core of the entire system. And you can also use it offline, and it has conflict resolution. So if you add something on one device, you add something on another device, it will just combine it. I think the best option, if you want to go with AWS, would be Serverless Framework. It has a cool CLI tool. It does configuration in YAML. It's provider agnostic, so it supports AWS, it supports Google, it supports Azure. Very cool. It's multilingual, so you can either go with Python or you can go JavaScript, it doesn't matter. It supports local testing of your functions and streaming logs, so you don't have to actually log into AWS and see what went wrong. It actually can show you in your command tool. So what about PHP? Well, too bad. There is a beta of PHP at Azure Functions. Personally, my experiences weren't very good. And also, a lot of brave people created wrappers for Lambda on AWS. So that allows you to run PHP in a Lambda function. Serverless Drupal, I don't think you should be doing it. As a proof of concept, you can try it, and it's a lot of fun. Just like people are doing it with Symfony and Laravel. Yes, you can do it. I haven't seen an actual working version of Drupal within Lambda. I fiddled around with it myself. I got pretty far, but there's no real point in actually doing it, I think. It would be better to just go with one Fargate instance like I showed before. If it's just using a headless CMS, then you probably don't need a lot of power anyway. There won't be any burst traffic on your CMS. So just have an instance, run it in a container, and do the rest around it serverless. If you do want to try it, find one of these wrappers that support Symfony's HTTP kernel, because that's also what Drupal uses, and then you can actually try it. But what's more interesting is static site generators, and the one I know most about is Gatsby. Not sure if anyone is familiar with it, but it actually, Drupal has a very good support for Drupal. So what it basically does, if you change some content, you can create a static version of your website. It will It will create a bunch of HTML files, and then you can put that in an S3 bucket and make it globally accessible. And then you have a serverless Drupal website. And whenever something changes in the admin, you just trigger a new build and update the bucket. Also, it's very secure because you cannot get hacked. It's all static files. Or go with any other headless CMS, like I showed you, Contentful, for instance. I did some personal stuff with that. It's very cool. Some tips and tricks when starting with serverless. A function should do one thing. So if your function is getting really big, probably you're doing way too much in one function. Also, functions usually do not call other functions. There are some use cases where it can happen, but usually you shouldn't be doing this. Avoid connection-based services, like for instance MySQL. It's not really suited for serverless because if you have to do connection pooling because you cannot do 1,000 simultaneous connections to MySQL. It will break. It will not allow doing that. So try to go with the services that are specifically created for this purpose, like DynamoDB or Elasticache. Also focus on asynchronous. If there's something you need to do, put it in a queue. And then have a Lambda looking at that queue instead of trying to do everything in a synchronous order. And play with memory size. This is really interesting. You can configure how much memory you're using in a function, but it's also directly tied to the CPU that you have available. So if you set it to 128 megabytes, that's the least amount of memory that you can use, it's also the slowest. And what you can do is try to maybe set it to 512 megabytes, and then also the CPU will increase. And maybe your function runs 5 times faster, and then actually it's cheaper because you pay more for how much memory you're using, but because it's running a lot shorter, it can mean that it's actually cheaper and faster. Just try it, just benchmark it. And you can pack it with binaries, like I showed you the example with the MP3 file. We packed it with FFmpeg, or for instance, or you can do it with lane encoder, and pack it with some other tool. That's also what they do with PHP. If they run it with PHP, there's actually a PHP binary in the package. Some next steps to explore. Looking at the time here. Right. Workflows. AWS step functions, and at Azure they have logic apps. And I won't go in this with very much detail, but this was one of the missing things with serverless. Like you want to do multiple things in series or maybe parallel. It wasn't really possible. You would have to throw data in multiple buckets and react on the changes in that bucket, and then eventually hope that it would end somewhere, right? But now you can actually make a state machine and tie certain functions together. So in this example, someone may upload a photo, and first you check, like, is this actually a valid photo? Maybe is it unsupported? If it's supported, send the photo to recognition, which is like a vision API where it can detect what's on the photo, and create a thumbnail at the same time. And when it's all done, then you can send it to a user or do something with it. But it makes sure that it's doing multiple things at once, and once they're all ready, then it goes to the next step. So there are state machines, and you can also implement something like human approval for this. And it requires less plumbing, because you don't have to put stuff in queues by yourself all the time. The system does it for you. Last thing I want to show is Lambda at Edge. And what this does, you can run a small function at the edge of your CDN. And also, I know that Cloudflare also supports it. So whenever a request comes in, you can do something with it before it hits your origin. And if it's cached, then it will just return as usual. And also you can do something, change behavior there. But you can also do it at the other side. When it actually does go to your origin, you can do something with it there before it reaches the origin. And also when it comes back from the origin. And it sounds really complicated. What can you actually do with this? Well, you can do rewrites, like URL rewrites. And rewrite some specific thing to a certain file in an S3 bucket instead. Or redirect. Maybe someone hits a URL and you want it to go somewhere else. You can set headers or check headers or remove headers, so that could be token validation, for instance. Or A/B testing. If someone comes in and they don't have a cookie, decide which group they fall into, and maybe rewrite something to a different URL based on that cookie. And this is one of the easiest ways to implement some A/B testing. Image resizing, extremely powerful. So whenever someone requests an image and it's not available yet in that size, you create it on the fly, then it gets cached and returned. Authentication. You can also have a Lambda function that checks the authentication. Is the token valid, for instance, like I said. And if it's not, you can just reject it before it reaches the origin. So some conclusions. What's actually the difference now between using functions and a VM or a container? Well, the VM can actually be stateful, and the function cannot be. VM can be long-lived, a function can't. Though if you're using step functions, it's kind of stateful, but still in a different way than a container would be. Also, you can use a container, if you are using Docker, you can bring your Docker container anywhere. And with functions, that's unfortunately not yet the case. If you create a function for Amazon, you cannot directly plug it into Google. There are groups working on this, but not yet. You cannot do this yet, so that's unfortunate. On the other hand, however, functions do not require provisioning, and you only pay for what you use. So if the function is never used, you don't pay anything. And it automatically scales, so if you have one user or 10,000, it doesn't matter. So I think there's a lot of advantages if you focus on code only, not on logistics. You never pay for idle. It scales with use. It's fault tolerant. And it's quite easy to get started with. Like, sure, you need to go into Python or Node, but I think everyone does some JavaScript on the side anyway. There's also some disadvantages. It's not always cheaper. Because if you know, like, I have this amount of traffic coming in every day and you don't expect any burst traffic or whatever, it could actually be cheaper to have that container running or that VM. You can have the issue with cold start, but sometimes it can take a few seconds. And of course you do have to learn new tools, and that can be frightening, but it's also a lot of fun. But it could be a reason not to do it. There is vendor lock-in. Like I said, the framework, the service framework, is provider agnostic. But once you start to use Amazon Q or a stream or a database, then it's very hard to get out of that. And testing and debugging, it's more difficult, I would say. And also monitoring. It's sometimes really complex to see, all right, I have 100 functions running, which is the one causing this issue, why is it not going from A to B? So use the right tool for the job, and it's okay to combine different tools. So my example showing a CMS there, it could easily be Drupal, and the rest is serverless. So that's it. Thanks for your attention. Are there any questions? Or did everyone fall asleep? There's a question up there.
Yes. They're gonna make me
That's one person that didn't fall asleep.
Yes.